Hi everyone, and welcome to our video on the Pythagorean identities. So the Pythagorean identities are a main part of the trigonometry class, kind of down the road though. So they introduce it here, and we can use them, and we will use it for an example, but there's other methods that we can use to also help us with the problems that we're about to see. Okay, so Pythagorean identities are nice. We'll use them a lot. This is just a brief introduction. All right, so Pythagorean identities, this is the main one, the one that I already boxed. Sine squared of t plus cosine squared of t equals 1. And where it comes from, okay, so if we want to know, let me scroll to a little bit of a blank spot. So if you have my notes, these were from a previous video, but I'm just going to mark over here. So remember our unit circle is based on the equation x squared plus y squared equals 1, where we have a terminal point, let's just put it over here, based on some t value, where we say, well, the x is the cosine of t, that x coordinate, let's mark the blue. So there's some t length. So we just say, oh, the x coordinate is the cosine of t and the y coordinate is the sine of t. Okay, so then x, again, they're saying is cosine of t, but it's getting squared, plus y, which they're saying is sine of t, but getting squared, equal to 1. Now, to avoid confusion with how the squaring works, they usually move the square to show it's the trig function getting squared. So cosine of t, all of it's getting squared. So they don't want to confuse just t getting squared. Okay, so let me mark another thing. So cosine, this would not be the same as this. So cosine of t squared is not the same as cosine of t all getting squared. So to avoid any confusion, in case they just say, if we didn't put parentheses on anything, then we'd say, well, which one is this? Which one is this? Okay, so we need the parentheses. So if they did, okay, there we go. Okay, now we know where that square is, and then now we know those two wouldn't be the same. Okay, so to avoid that confusion, in case we don't want to use parentheses, they move the 2, the power 2, to be in between. So it's showing cosine squared of t plus sine squared of t. Okay, and then they usually like sine first. So all they do afterwards is rearrange it. Whoops, and I pushed some key accidentally. Sorry, let me scroll. Okay, so they just like to rearrange it. So there it is, the boxed one. So sine squared of t plus cosine squared of t is 1. Okay, so that's, whoop, it keeps freaking out, sorry. There we go. Okay, so that is what that became. Okay, and then these other two, these ones are okay. These ones are nice to know about. But we really just need the sine squared of t plus the cosine squared of t equaling 1. That's our main one. All right, so, and then let's go ahead and also show where this second one comes from, this one that I just clouded. All right, so it comes from, I'm going to erase this in a second because we're about to do a problem. It comes from taking this main Pythagorean identity and dividing all of it by cosine squared of t. So if all of these get divided by cosine squared of t, then we would say, well, sine over cosine is tangent, but they are both being squared. That means tangent would still be squared. And then cosine squared of t and cosine squared of t, those are the same thing. So divided by itself is 1. And then we see, oh, 1 over cosine, we know that that's secant. However, it's being squared, so keep it squared. So secant squared of t. So that's where that second one comes from. Okay, and then the last one comes from a similar scenario right here, where we start with the original, but instead we divide by sine squared of t. Okay, so, but let me erase that, because I think it's going to be in the way. So if you do want it, copy it, pause me, but I'm going to erase that. So I can, there it goes, so that I know for sure I'll have enough room on this problem. All right, so given, all right, so now we're going to do this problem. So given tangent of t equals the square root of 6 over 2, and pi is pi is less than t, which is less than 3 pi halves, use a Pythagorean identity to find the values of the trigonometric ratios of t. Okay, so whenever they ask me to find the trigonometric ratios, I'm just going to go ahead and make my table. So they usually like to do sine first, but you can do it differently. I'm going to do sine of t, cosine of t, tangent of t, and then I hopefully will have enough room to, let's leave some space, but get their reciprocals. So sine of t's reciprocal is cosecant, cosine of t's reciprocal is secant, and then tangent of t's reciprocal is cotangent of t. So remember, once we have those three on the left, we just flip their answers for the other three. And they already give us tangent of t. So they say, oh, tangent of t is the square root of 6 over 2. That means I do have cotangent. We can do it now. Remember, it is, again, just flip your answer and then rationalize the denominator. Okay, so if we rationalize the denominator, which is to multiply both the top and bottom by square root of 6, we would have 2 square root of 6 over 6. The 2 and the 6 there do reduce, so square root of 6 up top, 3 on the bottom. Okay, so there's, just from that first piece of information, I'm going to block all this off. I think that should be enough room, I hope. Let's find out. Okay, so there we are. All right, so they give us tangent. Now, don't fall for this mistake. Don't say, oh, if they give us tangent, that must mean this numerator is sine and the denominator is cosine. No, that's never really going to be true. Okay, so because this tangent answer, so I'm going to erase that in a second. This tangent answer that I'm boxing and making bolder is a simplified fraction. One reason that these are definitely wrong, so sine of t and cosine of t, is our unit circle is so the unit means the biggest it could be is 1 for sines or cosines. Remember that 1 right there is the biggest cosine could ever be. So if I have 2, that means 2 somewhere over here. So 2's not on the unit circle. Okay, so that means that cannot be true. Okay, so don't just say, oh, tangent means I have sine and cosine. We don't. Okay, so erase those. All right, the other thing that we want to break down in this problem is this piece of information right here. Okay, so all I did so far was the tangent. This is telling us we're in a quadrant. Okay, so I'm going to mark that right here. They're saying the t value is between pi, so there's pi, and 3 pi halves. So there's 3 pi halves. So it's saying we're somewhere in quadrant 3. Okay, so we're in quadrant 3. So that means I'm gonna put that there. This is usually the biggest mistake students make, is forgetting about the quadrant. So we're in quadrant 3, which means tangent and cotangent should be positive. Yes, they are. Sine should be negative. So should cosine. So I'm going to set this up right now and just write a little thing in red to make sure, oh, don't forget, make sure those are negative, and tangent was positive. Okay, so I'm going to mark it in red to make sure I remember, make it negative, or make sure your answer is negative. All right, now we're doing the Pythagorean identity. So a lot of setup for it. All right, so this is where, so I did box this and said this is the most important one. Yes, it is. However, on this problem, it is using the second one because they gave us tangent. So we will do the second equation. So let's set that up. So tangent squared of t plus 1 equals secant squared of t. Okay, so they gave us tangent, so that's why we're doing this second one. So they gave us sine or cosine, we would have done the first. If they gave us cotangent or cosecant, we would have done this third clouded equation. Okay, and then remember, so this square, so that square, for now, I'm going to rewrite it, is saying your whole trig function is squared. So let's rewrite it for now. You don't have to in later problems, but I think it's a good idea for us right now. And then what they're saying is, well, tangent of t is that square root of 6 over 2. So you're saying all of this in the parentheses is just the square root of 6 over 2. And then still square it. And then still plus 1, still equal to secant of t all squared. Okay, and then the square root of 6 over 2, I can square. So remember, squaring a fraction, you square both the top and bottom. Square root of 6 squared is 6. 2 squared is 4. Okay, so we have 6 over 4 plus 1 is secant of t squared. Well, 6 over 4 is 3 over 2. Let's reduce it. And then we will need a common denominator, so let's just change the 1 into 2 over 2. There we are. And then 3 over 2 plus 2 over 2 is 5 over 2. So 5 over 2 is secant of t squared. All right, and then now I need to square root both sides. Remember, when you square root both sides of an equation, the numerical part needs a plus or minus on it. So plus minus square root of 5 over 2. And then the square root of 5 over 2, okay, so I need a little scratch work. Right, just like squaring, the square root of 5 over 2, so let's put my scratch work to the left. Let's get this set up though. So I want just secant of t equals, and then we'll put our answer there. But the square root of 5 over 2, so here's my quick scratch work, is the same thing as the square root of 5 over the square root of 2. Okay, and then that means we should rationalize the denominator. Again, they don't like that denominator to have a square root in it. So that means both the top and bottom get multiplied by radical 2. Now the radical 5 and the radical 2, or square root of 5 and square root of 2, is square root of 10. They do multiply and they stay under the square root. Square root of 2 and square root of 2 is just 2. There we go. Okay, so this is plus or minus square root of 10 over 2. And remember, square roots and non-square roots don't get along, so don't change that. That is the final answer there so far for secant. Okay, now we go back and say, well, we're in quadrant 3. If cosine is negative in quadrant 3, secant also is negative in quadrant 3. Okay, so we have our secant answer. So our secant answer is negative 2 over radical 10, just like that. Okay, except it would need to be rationalized. Oh, no, I'm thinking, sorry. I flipped it already. I was thinking cosine. Secant is just the negative radical 10 over 2. That is it. Okay, so that was our secant answer. And then now let's work the reciprocal. We can get cosine. So as long as so it's just flipping again. So if we flip the secant answer, so that's the negative 2 over radical 10. That's the cosine of t. And then we would need to rationalize it. So square root of 10 and square root of 10 multiplies both the top and bottom. And then we'll just need to simplify. So we get negative 2 radical 10 over 10. Well, the 2 and the 10 reduce. It's negative, I ran out of room, I was worried about that, negative radical 10 over 5. Okay, so that was the cosine. That's the cosine answer. All right, now that we have the cosine answer, one last thing. Let's go and erase. So there's my scratch work that I was erasing. I need the sine answer. Now we can go and use our main Pythagorean identity. Let's set that up right here. And I might need a little more room. I hope I can fit it all. And we can sub in the cosine of t answer. So we have, I'm going to do 2 steps in one. Let's rewrite that as sine of t all in parentheses squared plus cosine negative radical 10 over 5 in parentheses squared set equal to 1. And then we'll simplify. We've got sine of t squared. Now the negative is getting squared, which becomes a positive, so it's still plus square root of 10 is squared is 10. 5 squared is 25. Okay, so we have 10 over 25. We would need to subtract that over. Okay, so we've got minus 10 over 25 minus 10 over 25. And then we just need a little bit more scratch work again to the side here. Okay, so 1 minus 10 over 25 is 25 over 25 minus 10 over 25. That gives us 15 over 25. Okay, so let me erase what I wrote down in the blue underneath. So sorry, it's getting a little too tight. Okay, so I'm just going to show there was the scratch work to the side. And then we've got sine of t squared then is 15 over 25. And then last square root we need to do, let's square root both sides. Square rooting both sides, plus or minus. Square root of 15, let's put it right here. So we have plus or minus. Square root of 15 is the square root of 15. We can't do that. But the square root of 25 we could do. It is just 5. Okay, and then again, I'm back to the highlighted quadrant 3. Sine is negative in quadrant 3. So this should be negative radical 15 over 5. So there's our sine answer. And then our cosecant answer is to just flip it. So negative 5 over radical 15. And then one more time, rationalize the denominator to give us negative 5 radical 15 over 15. And then one more time, some things simplify. Negative radical 15 over 3. Okay, so that's a long one, huh? Okay, so it's using those identities, a little bit of scratch work needed. Okay, but make sure double check your signs at the end. Quadrant 3, yep, all good, done. Okay, so anyway, that's it. We'll see another method to do these problems. Okay, so this took almost 20 minutes. We'll see another method soon that can do these also using triangles, right triangles. But this is one for now. Okay, so thanks for watching. If you do have questions, please let me know. Otherwise, I'll see you again soon.